Let's look at some quadratic equations and functions. Here comes the first one. Which equation is equivalent to this one? So when you look at them, what's actually happening is all these four choices are coming from vertex form of quadratic function, meaning we have y equals a x minus h squared plus k. Now, in order for you to get to this point, what you need to do is you need to have the completed square. So how would you be able to do it? If I were to rewrite this one, y equals x squared plus 24x, and then I'm going to leave myself some space here, minus 18. Now, the number that you need to complete the square, you're going to divide 24 by 2, then we get 12, and we have to square that, which becomes 144. So since I'm going to add 144 to complete the square, I have to subtract the same amount to undo of adding of 144. Now then you can see the first three terms becomes a perfect square. So here we have y equals x plus 12 square. When you factor these three terms, you will always use the number that you divided by 2. They will always match. Now, secondly, we have to combine these two terms, so we get minus 162. So what we end up getting is choice 1 becomes the answer. Alrighty, let's look at the next question, number 2. Same idea, which one of them is equal to, so then I'm gonna rewrite this one as x squared plus 12x. Now notice that my one side is perfect square, all the other numbers are on the other side. So I'm gonna add 15 to both sides so that this is how I'm gonna start. Now, which number do I need in order for me to complete the square? I'm gonna divide this one by 2. So I get 6. And then I'm gonna square that, which means 36 is what I need. So I'm gonna add 36 on both sides. Then on my left side here, that becomes x plus 6 squared. That's what we end up getting. On my right side, it becomes 51. So we get x plus 6 squared equals 51. Choice 4 becomes the answer. All right, number 3. The quadratic equation here is rewritten in this form. So once again, we are dealing with the same thing here, which is complete square. So if I were to rewrite it, x squared minus 10x equals 5. You tell me, what do you think? Of course, I cannot hear you right now, but let us say I could. Which number should I add in order for me to complete the square? So I'm going to divide that by 2, which is negative 5, and then square that. Then it's plus 25. So I'm going to add 25 on both sides. Then on my left side, what I'm getting is x minus 5 squared. And on my right side is equal to 30. Now, in this case, we are looking for the value of p. Then the corresponding value here would have been negative 5. So choice 2 becomes the answer. All right, let's look at number 4. So in this case, things are already squared. So then how am I going to find the value of x? So first what I like to do is I'm going to divide by 2. So we get x plus 3 square is equal to, that's right, 49. Now, when I get rid of the square by taking the square root of each side, x plus 3 becomes plus or minus 7. Alright, then how would you be able to find the value of x? I will subtract 3. Then x becomes negative 3 plus or minus 7. So first, negative 3 plus 7 becomes 4. Negative 3 minus 7 becomes negative 10. So 4 or negative 10. Choice 1 to be our answer. Alrighty, let's move on to the next problem. Number 5. The graph of a quadratic function is shown below, right over here. This is the parabola, and that's x-axis and y-axis. The question is how many real solutions. When they say real solution, that's the same thing as x-intercept. So how many x-intercepts do you see? I don't see any. That means you don't see real solutions from this function when it's set equal to 0. So what we end up getting is, the answer is 0 because I don't see any intersections. Alrighty. Number 6. We're looking for the minimum value here. How do you get the minimum value? You see, in case of a parabola, minimum value or maximum value in parabola happens at vertex. If you remember from in the first problem of this question, we talked about how we can rewrite how we can represent parabola in vertex form. So then if I have to rewrite that, y equals a x minus h squared plus k, and then we realize the vertex is at h comma k. Now, and we're looking for the minimum value when x is. So I'm looking for the h value. Notice that in front of h there was already negative sign. So what does h correspond to from here? That's right, h corresponds to 2. So therefore, x value in this case would have been 2. Alright, so with that, we are done. I'll see you later. Bye.